Three different skins will be applied to the project. Each will include green building materials. These three skins will be compared in terms of energy and lighting performance. After choosing the best skin, mechanical cooling will be turned off, and a natural ventilation strategy will be applied to the building integrated with AHU hybrid system. Active PV panels will be applied to the south elevation end. Final energy performance of the building will be compared to the base case to find out the total percentage of energy reduction. The project is located in Palm Jumeirah, Dubai. First of all, we conducted site analysis that shows the sun pass overhead. The most preferred direction is northeast. Now, let me take you through a few more details about our design. It's a two-bedroom villa of a total built-up area 380 square meters that consists of 3 floors. With the master bedroom is located under the seawater level. And here, you can see the ground floor and first floor plans, perspective and elevation. Before we go through the 3 different skins selected, a base case villa was analyzed using IES simulation program, adopting the commonly used building materials. Using Apache Sim application, the annual total energy consumption and cooling loads summed up to 73.8 and 108.2 megawatt hours, distributed as shown in the graph. While the difference in cooling rates between underwater and first floor bedrooms was 70%. Different skins were investigated. In the first skin, extra insulation, air cavity, and an exterior wood layer were added to the external walls, in addition to low thermal conductivity green concrete. Now, let's go through the analysis of each skin. In skin 1, after applying the proposed materials, it was found that the total energy and room cooling summed up to 65.2 and 91.5 megawatt hour. Comparing the results to the base case, total energy and cooling loads were reduced by 12 and 15% as shown here in the graph, while the difference between first floor and underwater bedrooms was 66%, reduced by 4% than that of the base case. In skin 2, louvers were added to south, east and west elevations. Total energy and room cooling reached 57.4 and 75.8 megawatt hour. Comparing the results to the base case, reduction percentage of total energy and cooling loads reached 22 and 30%, while the difference in room cooling loads between the 2 bedrooms was reduced by 20% than the base case. In terms of lighting performance, in the ground floor, the maximum daylight factor was reduced to 24.3%. Uniformity and diversity were enhanced by 66%. In the first floor, the maximum daylight factor was reduced to 23.4%, while the uniformity and diversity were enhanced by 24%. As a validation point, Rivet lighting analysis was used to compare Skin 1 and Skin 2. It showed that both cases had enough natural lighting. While in the third skin, to provide the same effect of the underwater floor and reduce cooling loads, a water layer was designed to move over the building envelope. Adding the water layer to the building has reduced the total energy and cooling loads by 33 and 44% than the base case, while the difference in room cooling loads between the underwater and first floor bedrooms was only 3%. In order to enhance the energy performance of the project, the following building envelope and special insulation details were applied to the building, divided into 6 main types: roof, external walls, curtain wall systems, exposed ground floor, and internal flooring details. Added PV panels provided 23.9 MWh per year, which is equal to 48% of the total energy consumption of the building. Mechanical cooling was turned off from December to March. External CFD analysis was performed. Results showed the maximum air velocity that hits the building. Positive and negative air pressure areas were identified, and a field contour slice was taken to show the wind direction on Z-axis. While internal CFD analysis showed that the highest wind velocity with the lowest temperature is located on the highest point of the stair. This is the location where the air handling unit will be placed. In winter, with the help of this air handling unit hybrid mechanical system, the project will depend on natural ventilation as the main source of cooling inside the villa as shown in the sections. Finally, the total energy consumption of the building is 49.7 MWh, saving 23.9 MWh from renewable resources, which is 48%. The total reduction is 33% compared to the base case.